Hello everyone, this is lab 4 and this lab is all about derivatives and its relationship between function. So I'm going to introduce a new command this lab uh, and the same command is used in the next lab as well. So as usual, I've created a MATLAB file. You can see it right there, and this MATLAB file has all the necessary information that you actually need to solve the assignment questions. Okay, try to stick on whatever I've done so far and everything should be easy. Okay, so this lab is about derivatives and its relationship with functions. So what we do is we see how a function and its derivatives is related to. So first, let us see how to use a new command to take a derivative of a function. So let's say I have a function sine of x squared, just like that. I have a function x squared. Then if I want to take a derivative of that function, I'm going to do it like this. So let's say df is derivative of a function, that is equal to diff of, within parentheses you have to say f and x, where x is the variable with respect to what variable you are going to take the derivative of. So I have x, so I'm going to take the derivative with respect to x, so I have x at the end. So that is the command. So we will use this command for most of our lab, so please note this. Okay, now this is okay, but we can also find derivatives using function. Of course, we have seen a similar kind of function called mysolver in our first two classes. So what we will do is we have a new function that is called f and f prime. Let us go and pick it up. So as usual, we have to have our function in our script file. So copy that and paste it in the script file, new script, and save the function in the name of the function itself. Okay, so when you go to save, MATLAB automatically by default asks you to save in the name of the function itself. So the function name is f and f prime. By default it is f and f prime. I've already saved it, so I'm going to replace the same thing. So what happens here is your f is the function, x minimum and x maximum is the interval. That is, when you plot a graph you obviously mention x and x max, right? So it's the same thing. Now y minimum and y maximum is the y interval, and the author is the name that you want to give to your graph or the plots. So when you give all the data in your live script, when you define f, when you define x minimum, x maximum, y minimum and y maximum and the author, this entire function takes those data and processes like this. So f and f prime will take the derivative of f, then my window, so that is the intervals, right? Then you're plotting the graph, so you're plotting f is the function, in the interval my window, where my window was x minimum, x maximum, y minimum and y maximum. Hold on, because you need another plot, and that another plot is your derivative function f prime. So you're taking the derivative and you're also plotting that derivative function in the same interval as x minimum, x maximum, y minimum and y maximum, and then you're switching on grid to make things easier, and then you're giving a name to that. So that's what we do here. So we have a new function wavy. Instead of f, we can have a fancy name, say wavy, or say h of x, g of x, k of x, l of x, whatever it is, but still it's a function of x. So wavy of x, that is equal to 2 times sine of 3x divided by 4 plus 4. So that is the function. Now instead of taking the derivative, plotting the function, then plotting the derivative function, defining the intervals, we can do everything in just one single step, that is by using f and f prime function. So I'm going to call that function f and f prime, and inside parentheses I need to feed all these data that I defined, right? I need to say which function that I want to find the derivative and then plot, and then the intervals with the name. So that's what I'm trying to do here. My function is wavy, my x minimum is -10, my x maximum is +10, and y minimum is -10 and y maximum is +10. So I'm going to give the name as lab 4. You can give any names, and you must make sure that whatever name you give should be within the inverted comma. single inverted comma. So the reason why we have wave is because the curve is wavy. That is the reason. So when you just use that function, you have this huge graph with, right, this huge graph. Now if you look at it, your blue line is your function, your red line is the derivative of the function. You can plot it separately and then check it. It's not that hard because we have seen this. Use easy plot wavy of x in that interval, hold on and use derivative and find the derivative separately and then plot it separately. You'll see which one among those is the function and which one among those is the derivative of the function. Okay, so when you do this separately, you will easily find out which one is what, which curve is what. So the blue line is your function wavy and the red line is the derivative function. Okay, that makes few things clear. Next step is to find flat spots. Now last class we have seen what is a horizontal what is a tangent. A tangent is a line that runs along with the curve, right? So but flat spot is nothing different, but it is a horizontal tangent. It's a horizontal tangent, so it's a horizontal line. Now if you look at the graph, you have a horizontal tangent right here at x is equal to -6, somewhere close to -6, right there, right there, right there. Now let us only look at x is equal to 6, okay, somewhere there. I need to find at what point of x I have a horizontal tangent in the function. Now this lab is about relationship between derivatives and function. So what we have to do is we need to solve derivative function to find the horizontal spot at a function. So what we do is this. Of course, by looking at the graph, you can clearly see that at x is equal to 6, you have a horizontal tangent. Now if you again look at the red line, at the same point in the red line, you have a curve meeting at 0, right? So that means whenever your derivative function is 0, your function is 0, you have a horizontal tangent. So whenever a derivative function is 0, you have a horizontal tangent. That means you need to solve for a derivative function to be 0. You need to find an x value that makes your derivative function 0. So that's what I'm trying to do here. Now what I've done is I'm just focusing on this little interval 5.8 to 6.3 and -2 to 3. So that gives this graph, the graph right here. So -5.8 to 6.3. Okay, let's move on to 6.8 because that will allow us to look at the graph more clearly and then judge. So wherever your derivative function is 0, so derivative function is 0 at somewhere between 6.7 and 6.8. Oh no, 6.3, somewhere at 6.3, right? At the same point you have a horizontal tangent. So let's look at more clearly at what point we have a 0. So to do that, what we do is we use VPA solve command. Of course we have seen this in our first class. We have seen how to use a solve command to find an x value that makes a function 0. So what we do is VPA solve. I'm going to solve my derivative function to 0 to find the value of x close to 6. Okay, I'm using this 6 very cautiously to see that all my solutions are close to 6, right? So I'm going to what I've done here is I am trying to find an x value. I'm trying to find an x value that makes my derivative function 0. So if I find that x value that makes my derivative function 0, it is the same point of x value my function has a horizontal tangent. So when I do that, when I use this command, that is what I have, 6.283185 and so on and so forth. So that is the x value where I have a horizontal tangent. Simultaneously the derivative function is 0. So in your assignment question, you just have to follow the same procedure by just changing the name of the function and the equation, then the intervals, and then you have to clearly look at the graph and then answer most of the questions that is asked on the assignment part. Okay, that's not that hard. Now for example, one of the questions says that you need to find where the function is decreasing or where the function is increasing. So I'll give you a little example. Now this is the function graph f, right? Now the function is decreasing from -6 to -2, right? By looking at the graph, it is very clear to us that from -6 to -2 the function is decreasing, and from -10 to -6 the function is increasing, something like that. So look at the graph very clearly and then answer most of the questions that is asked, because all the questions on the assignment part is clearly from looking at the graph, and there is nothing new that you are going to do. I don't think you'll have questions anymore on this. So the function name and the equation, then the interval. So this is x minimum, x maximum, y minimum, and y maximum. Okay, that makes few things clear, and that is the function. You just have to simply follow that procedure. I mean, use f and f prime. Okay, you have to use f and f prime, then the function. You'll clearly get two curves on a graph. Look at the graph and then answer the rest of the questions. I think that answers most of the lab 4, and feel free to ask questions if you have any. See you in lab 5. Thank you.